Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of pgMustard, and this is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we talking about today?
Hi Michael, let's talk about materialized views skipping regular views. Or you want to talk about them both?
Well, I was most keen to talk about materialized views, but it's difficult to define them, I guess, without mentioning views at some point.
Right. And the rule system.
Yeah.
Right. Well, yeah. And regular views also interesting. They have also interesting things to discuss, right? So yeah, let's focus on materialized views, but briefly touch regular views. And as usual, let's start from very simple things and definitions for those who are not really familiar with views system in Postgres, and then try to dive into deeper topics and future maybe a little bit, right?
Sounds good. So there's I guess let's even go back. Let's think about tables, relations in general.
Yeah.
We have ways of storing data in Postgres. We have tables, which hopefully everybody's familiar with, and then views, which are kind of a virtual table. So we can set up a query that queries tables, or let's stick to that simple version and call that a view. But that doesn't store anything. That's like it's a view into the data. But our queries, if we're querying a lot of data in the tables, we're still going to be querying a lot of data via the views. Whereas materialized views are
let's rephrase about the whole this area is based on the fact that any query returns kind of a table. What is the table? It's a good question because, for example, in theory, all rows in the relation, all tuples in relation should be distinguishable. In Postgres, it's at primary key is not required, so they can be not distinguishable. But if you also remember about hidden columns, CTID, Xmax, Xmin, we discussed a couple of times, they are distinguishable again, but result sets of queries don't have those invisible columns. So it's kind of a lot of nuances here, but in simplified point of view, any query returns a table, right? Which means we could use could substitute some table in some query with another query, and vice versa. We could take some subquery and say we can put a name for it and store it as another query and just use this alias here, right? And this is actually a view. And in Postgres, views are implemented using rule system, which is very, very old thing. Originally, Postgres and maybe Ingress had many decades ago. And this rule system allows users to define some rules, saying what to do at planning stage, not an execution stage as triggers, but at planning stage. So instead of this, do that. So we can say when you see select from view 1, just do this subselect from there and then do what you want. And this rule system allows you to define views. And also, good thing, by the way, it was my bachelor's thesis very long ago, updatable views. So you can even insert, if views are quite simple, and Postgres can propagate change. So you can not only select from them, but you can insert to them, update, delete, and it will work. And by the way, some intermediate software like Postgres, and for example, if you are a Supabase user, you are using Postgres, it encourages you to define API using views, and it relies on the fact that you can change data, not only read data there, and it's quite interesting. This is views, right? Based on rule system, not approaching execution step of query execution, just doing everything on the planning stage, right? So quite good, quite interesting. What's the main problem with views? Like dependency hell. if you need to change underlying table or underlying views, if you have hierarchy, multiple layers, you usually need to recreate your views. So it's can be painful, especially if your system is under constant high load, heavy load. Mm-hmm.
Yeah. And I think the benefits of them are extremely different to the benefits of Materialized. So do you want,
very different.
Like when do you see views used most often?
Well, originally, I remember from my bachelor thesis, like 20 plus years ago, originally one of the key ideas is that this is helpful to control access. So you can restrict like number of columns you expose via views. You can also restrict number of rows, so you can do it in both dimensions of table, columns and rows. And then you can have very different, you can provide, for example, writable access in view, but no direct access to table at all. And this is actually what Postgres is doing. You're supposed to have a separate schema, and there you define views. And nobody is working, like users of your system don't work directly with table. They work with it via views, which it's helpful to manage access. Also, views are helpful. Sometimes just shortcuts, like alias for your queries. Why not?
Yeah, usability, right? Better names, but that you can give objects different names to make them. You know, if you regret a name and don't want to actually do a big migration, I've seen it used for that as well. Right. But yeah, the main one seems to be security.
They add complexity to system, definitely, yeah. And especially if you have several layers of views, so you will end up dealing with, like, if your schema is changing often, it will be you will notice overhead of maintaining your views constantly. But what else? Like, where are views helpful? I don't know. Actually, reporting, like you have reports, so you just store it and that's it. But it doesn't help with speed.
Well,
it's because it's just
exactly
that.
Yeah,
it's just it doesn't store any statistics. It doesn't help you. You cannot create index on view, nothing like that, because it's very ephemeral. It's like just a query stored under some name. That's it. This is view.
Can it ever hurt performance in terms of push down for like predicates and things like that?
I'm not so sure. Like in some cases, of course, if you have a view, you have indirectly you have less flexible ways to optimize your query. But like in most cases, Postgres planner it can choose what to do. Like there is this join collapse and another collapse.
From collapse?
Yeah, from collapse setting. So it can. It basically says that Postgres compares different paths easily, and views are already substituted at optimization time. So it's just they already this query which defines the view, it's already there, right? So basically, I don't see big problem. Main problem only about maintenance of schema changes. For me, from my experience, I might be wrong, of course, as usual. Like my experience is, it's not the only one, right?
Yeah. Get in touch.
So materialized views, another idea. I would say it's opposite idea. Instead of just storing the view definition, let's store the data and view definition as well, right?
Yeah, importantly, but it's storing the data. And at the moment, that's at a point in time. So when the materialized view was created, so it's that query run at that time. So that, and again, let's probably want to catch me before I go into the benefits too quickly. But the idea is you can run an expensive like computation of data, or you can do some work once and then read from it a lot of times instead of having to do that expensive work multiple times.
Right. Actually, you can define materialized view, but don't have data in it originally. There is an additional command populate.
What's the benefit of that? I couldn't work it out.
Well, I don't know. Some cases we can invent some cases synthetically. For example, you restore from dump, and you don't need it yet, but you already restored your the original data. This because Materialized View, it's the data which is derived. You always can refresh it and have a up-to-date version. So you restore from dump, and you don't want to have it there yet somehow. Just to consider dump as already restored fully because all original data already there. And later,
sure, so it speeds up. Yeah, so
right.
you can
And
speed
later
up the restore.
in separate step, it can be done using pgrestore pgdump pair of utilities, and pgrestore has -l uppercase and downcase L pair of options. So one option provides the list of objects the dump has, which if dump is in custom directory format, and another option allows you to filter out everything you don't want to, or you filter in what you want to restore. So you can restore Materialized View, but don't restore data, and do it later separately. This is actually I did it, but I did it because I had issues with. By the way, maybe it's still there. So if you have multiple Materialized Views and also multiple layers of them, like hierarchy,
Yep.
right? In some cases, restore doesn't work because it doesn't know the order.
Yeah.
And it says I cannot populate data yet for this Materialized View because I depend on another Materialized View. It's empty, or maybe even not created at all. I don't remember details there. But so I remember I wrote a script to with like infinite loop.
Yeah.
And if refresh Materialized View fails, just skipped, and another attempt is done later. So it was brute force, recursive refresh of all Materialized Views to fill all layers of it. It worked very well. Like, I mean, if you just catch this error and do it later, nobody cares. So in the end, you will have all Materialized Views fully filled with data. Data is populated.
Yeah.
And this is where I needed to skip population of data originally using pgrestore -l underscore and dash uppercase and lowercase. So Materialized View stores data. I agree with you that it's helpful to avoid, for example, aggregates. One of examples, because we all know that counting is quite slow in Postgres is a raw store, so it's not column store, unlike some analytical database systems. And of course, if you have billion rows, count will be slow. Even if you have index-only scan, it will still be slow. So you can pre-calculate it for particular groups, for example, and have quite small Materialized View, and you can build indexes on it, any custom indexes, right?
Yeah.
So
I think a lot of people don't realize that. It's really cool.
Yeah, it's because it's a table actually.
Yeah.
I would like everyone to understand that instead of Materialized View, you have very good, powerful tool in Postgres. Create table as select.
Yes.
It's considered as a one-time Materialized View, like without refresh capability. It's the same. Right?
Yes. But with refresh capability, I think it becomes even more powerful, right? Like
I would argue. I mean, I agree in many cases, but in some cases I don't agree, and I will tell you why in a moment. So,
awesome.
Create table as select gives you powerful ability to do some derived table, create some derived table based on one or several other tables or Materialized Views actually, and then create indexes and work with it. Very good for experimenting. It's also very good, and internally it's good. It doesn't spam the buffer pool, because the ring is used there, so only small amount of buffers, relatively small. I don't remember, always forget the size of it, but of course the page cache of operational system page cache, it doesn't have knowledge what data you are getting from disk, so it will be spammed with this action. But the buffer pool will remain good. I mean, it won't evict useful buffers from your system, which is good, creatable as select. And you can create indexes. And I would like to point to very important thing I realized not very long ago. Very simple. I like to say silly things. By the way, I want to apologize for the last episode because I said inserts cannot be had, heap only tuples, and deletes cannot be had. Well, inserts cannot be had. It's like doesn't make sense. But deletes, they even don't change indexes at all because indexes don't have visibility in for. So it was a wrong idea to raise. Delete, as we also discussed, it just puts value of transaction ID to xmax in the heap in table pages, and doesn't do anything with indexes at all, and so it cannot be had because it's not needed to be had at all. Right? It's already had actually. Like new statement, deletes are always had already because they don't change indexes. And of course, indexes are changed later by vacuum activities, but it's asynchronously, which is good. So back to our topic, the idea that you can create table as select or create materialized view, which currently we can consider like quite kind of equivalents. We will see differences a little bit later. You can create indexes, and this is super cool because if join is involved, you cannot create an index on two tables at once. Index always belongs to some table. But sometimes, for example, you want to order by two values which are present in two different tables, or you want to order by and filter, and you could do it using single index scan, both order by limit and order by and where clause uses one column, order by and limit another column. We could combine it in an index, like two-column index, for example, but we cannot because these columns are in different tables, right? So we cannot create an index for two tables. But when you join and create table as select and join, or you create materialized view, you finally can have this index, even if you don't do anything with data except just joining it and have everything.
Yeah.
Right.
I mean, that's awesome. I've not seen anyone doing that, but that's such a cool idea.
I think everyone doing it just implicitly.
Oh, interesting. So in fact, this actually takes us quite quickly to one of the downsides. Like that's great, but you are. It's a minor downside, I guess, for most people, but that is taking up space on disk, in cache,
well,
in
of course,
caches and things like that.
Materialized to take space, and create table as select would take space, right?
Yeah. So it's a minor downside for that benefit, but it's the reason why.
But the speed benefit can be many orders of magnitude, because when you avoid join and you can have single index scan and maybe even index only scan, compared to two index scans in two different tables and then one of three algorithms to join it, like it's like game changer could be in terms of performance.
Yeah,
right?
I completely agree. The other, like, I think while I'm talking about downsides, the main one.
Before downsides, just emphasize, like you can, instead of putting query which will solve your like you have some goal to do something with data, and you have a query. You want to improve it, the speed of it, and okay, I will basically what is this create table as select or create materialized view? It's kind of cache. Instead of considering it as a query cache, you could, for example, store more, have more indexes on this derived table or materialized view, and have more for future. You can support more queries with this cache. Like cache, not the final result, cache data, right? So as we know, query cache is kind of it's good until it's not, right? For example, MySQL removed query cache from engine at some point.
It feels like one of those things where there are use cases that it can hugely benefit. Like if your data's not changing much, or if you have past data that it's okay.
You're pushing us too fast to the main problem with this approach.
Well, okay. But I think it's
which
difficult to
also
talk
one of two biggest problems in computer science, as we know, right? Cache and
Yeah.
validation. How to maintain the state of it, not to. Of course, when we say create table select, or we say create materialized view and populate data, there, of course, we have the data is frozen, right?
Yeah, but I mean, like, if we're talking about some people do have analytics databases from static data that isn't changing at all. And for that,
I
there's no
doubt.
downside.
Well, maybe some cases, right? But I mostly observe cases when people want to maintain the state of analytical database with very small lag.
Yeah.
Maybe this is,
Yes. If people want
or
everything.
even they want to have it in the same system, so in Postgres and so on, so like HTAP approach. So.
Hybrid, right? Hybrid transactional.
So yeah,
and
the main problem is how to update it, and what Postgres offers. If we forget about my idea of create table select, which I still think is quite good and it can beat materialized view in some cases, I will explain why. Like I keep this like intrigue state. So we can say refresh materialized view, right? Refresh
and importantly, I didn't realize this was added so early, but refresh materialized view concurrently as well.
Right. What's the difference? The difference is one will lead to bloat, another will not, right?
So the big difference, and I looked it up.
Like developer's point of view, it's so good. Our queries are working. DBA's point of view, bloat in materialized views. Who knew it can happen as well?
Right. So if we refresh a materialized view without concurrently, we block selects on the materialized view while it's refreshing, right? And that's offered, bear in mind we're normally doing this on a slightly slow query because that's the benefit of materialized.
It's like vacuum full, basically, right? But data will be fresh. Our goal is achieved.
Yes, but with concurrently, it's like I guess the equivalent would be a PG repack or something, or create index concurrently, reindex concurrently would be the equivalent. So with concurrently, we don't block selects on the past state of the materialized view, and it replaces it once it's finished.
Right.
Is that right?
Yeah, that's right. But the main point to remember here is that we can refresh it only fully. We cannot refresh part of it, unfortunately.
Yeah.
If we use regular materialized view, like original Postgres provides, because just refresh materialized view concurrently, that's it. There are no options say that I know 90% of my data hasn't changed because it's very old data, so I probably could do it much faster. And so you refresh everything, and it can take a lot of time. But concurrent selects are working. It's good. But we accumulate bloat, of course. And the indexes, if we follow my approach, let's not use materialized view. Let's define materialized view with some underlying data, maybe raw data, and support more queries, more kinds of queries with it. It means that probably you have multiple indexes there. Oh, we forgot to say that to support concurrent update, refresh, we need a unique index.
Exactly. Right. On one of the columns, right?
It's at least one. So already one index is there. But if you follow my approach, let's have raw data and support more queries, you probably have multiple indexes there, and their health will degrade as well. So all problems we have with tables which receive significant numbers of updates, deletes, we will have this here as well. So repacking or something. And here idea, why just not to recreate it if we still need to populate it fully, right? Why? And maybe it can be just recreate materialized view with under a different name and then quickly swap it in single transaction, or just this create table as select. It's if it's recreated every time we want to refresh, what's the point of having materialized view? Just maybe convenience, because definition of it remembers the query right? So it like database system stores the definition. It's better maybe. That's it. In some cases, I would seriously consider recreation of it every time, just to not to deal with bloat in data part of it and in indexes we have on it, right? But of course, if we do it every minute, for example, I would check the bloat of system catalogs as well, because if you have a lot of DDLs, you consider DDL is very, very often thing to happen. You probably might end up having very bloated PG class and so on. So it's also worth remembering. And PG repack cannot repack system catalogs, so you need to do vacuum full. Fortunately, it's usually very fast. But you don't want to be it like to have a 99% of bloat or something, because it will affect a lot of basically all queries. So, because planning will be slowed down and so on, like many things. So bottom line, refresh Materialized is good, but it's very, very rough tool. One of our customers enjoyed using them until some point, and then said it's like having a huge hammer and just applying it to very small things. Like it's very rough tool, very rough. So it saves you sometimes, but then like if you only small portions of your data is changing, maybe you will be not satisfied with this approach. Refresh it fully always. And here also, like, by the way, could Materialized View be updatable?
Do you mean increment? Like, what do you mean?
Updatable means like in the same, we discussed it for regular views, you can insert it. I don't
see how that would make sense.
Well, it might make sense at some point, but maybe it's too like exotic. And I suspect other systems have it, but I don't remember. Let's skip it. Just a question to know, just entertaining question. But as for the main topic, like what would we need? We would need to be able to update only parts of the Materialized View, and there is a big theory described in, not big, but some theory described in wiki page. Postgres wiki page, and the discussion is happening already many years, maybe decades, at least 1 decade, I would say, to have incrementally maintained views, incrementally refreshed or maintained views. So we want to avoid full refresh, right? We want to adjust only part of it. And since I already brought this, that Materialized View, it's like create table as select, but with rule system from views inherited. Like we just remember this. You can use create table as select and then maintain the state using triggers or some other things and have incrementally updated. If you understand the logic, probably it's the good way to go, right? Just to maintain from your application. The question to this approach will be, do you lose data? And do you slow down your writes on the baseline base tables?
Exactly. What are the trade-offs? It's actually quite an interesting time to talk about. We could talk about the future and incrementally updating Materialized views in Postgres, but I think it's also worth talking about a couple of existing tools and systems that have partially tackled it or tackled it for their own specific case. The reason, this was a requested topic, so thank you to the person who requested it, but there was also an announcement, not in the Postgres space, but by a company called PlanetScale that we've talked about briefly here before, that announced a boost feature that looks very similar to Materialized views, but with incremental updates
And boost is easy to achieve if you had a join or multiple joins with a lot of various kinds of index scans, and then suddenly you have index only. I'm talking Postgres terms. Then suddenly you have single index only scan. Of course, it will be like 10,000 speed improvement or 100,000 even sometimes. So
they definitely went for a clickbaity title on it, but it's kind of what people sometimes want, right? They've got a slow query and they
But
want a
what's the
quick
price?
fix while they, yeah.
I'm not concerned about the space, additional space usually, but sometimes
Exactly.
I do. But the price of maintenance, how maintenance are organized. Do we have bloat issues in Postgres if we do this?
Yeah.
So
The other one I wanted to talk about as an existing, Timescale have their continuous aggregates feature as well, and we don't need to discuss them in depth here, but there's a good blog post that they've done actually covering some of the topics we've just discussed about views, materialized views, and continuous aggregates. And they have a solution that it's designed for time series workloads where you're probably not going to have loads of data in the past changing, but it can cope with that, and they're being improved. So that's an interesting take if that's something you want and need, and you're okay with the trade-offs. Now it exists, and it's kind of it's in this area topic of incrementally updating.
if you're a timescale user, you should go and check continuous aggregates. 100%.
Yeah.
This is one of key features, I would say. I agree. But there is also project, and there is discussion happening almost 4 years already in Hackers. Unfortunately, it's I don't know details, but I just see it. Implementing incremental view maintenance started in December 2018 from Yugo Nagata, and the same offer created PG IVM project, which is it's
an extension.
Extension,
Yeah.
okay. Open source extension. It's quite good, interesting work. And this is attempt to follow this approach, like let's have incremental updates, partial updates of automatic partial updates of view. But as I understand, like I've spent some time understanding how PG IVM works. First of all, there are restrictions, of course, on queries that can be used to define such views. And also, as I understand, there are two approaches. First is synchronous propagation of data change, which will slow down our original insert or update or delete, right? But still, it's good. It's good thing to have it automated.
Yeah, I think of that as immediately updating materialized view. So as soon as there's
synchronously,
change,
immediately, right?
Yeah,
it means that at commit time, like our transactions which changed the original table will slow down, of course. But it's good that we don't need to write a trigger to do it. And the second way is to have refresh. I didn't get it. Maybe like it's still full refresh, like before, or no? Like I didn't get this part.
I think they use triggers.
Right. Okay. So it's if I updated only one row out of billion, will second option will propagate change very fast compared to refresh materialized view.
I didn't realize pgIVM had two options. I thought they might be talking more philosophically about there being two options, and that was my understanding. But I definitely might have. There's a good video by Lucas Fittel on this as well.
Yeah.
We mentioned his channel last time. I'll link up that video. That's like a 5 minute.
Keep mentioning this channel, and unlike us, our podcast, it's only 5 minutes always. Very much faster for those poor dog owners who work with dogs only 5 minutes.
Yeah, maybe ones with little legs. Yeah,
right. Right. So why I think still this is great, but two big questions to this direction as a whole. First, can we do it asynchronously, but like propagate it always, but asynchronously? Like first option, but asynchronously. I don't want my original transaction to slow down. And second, this is usually needed when we have a lot of data. And when we have a lot of data, we always should use partitioning. I want my materialized view also partitioned, maybe, right? So what about this? Like if we consider it as because some part of it will be changed. Like for example, we partitioned by months, and we have very 5 years ago data, January 5 years ago, for example. It still can change, but so infrequently. So I would refresh it very less often, right? I don't want my original tables be partitioned, but materialized view is a single thing. It means that If I refresh it fully, it's very slow query, and it will affect vacuuming and will affect whole database, leading to bloat in all tables. If I update it partially, well, I'm fine actually, maybe fine to have. Well, vacuum will also need to work here as well, right? And if it's a single huge table, all problems we have with huge tables which are not partitioned will hit this materialized view as well, even if we have partial incremental view maintenance.
Yeah. So if I understand you, we're kind of talking about two extremes and like whether there's a middle ground. So there's the extreme of having to refresh everything each time, which we currently have in Postgres. There's the other extreme of synchronous, immediate, trigger-based updates, so that our materialized view is updated on each transaction, but that comes with write overhead. Is there a middle ground option where we can?
There is perfect solution. It's not middle ground. It's perfect solution. Perfect solution should propagate data asynchronously, not slowing down original transaction and not losing data. With some small lag, ideally also observable. So I would put this lag to some, I don't know, monitoring. And second, the result should be partitioned.
This is where you lost me a little bit. So my understanding of materialized views is normally that they're hugely smaller than the original data. So I mean, how big are these materialized views?
I don't agree.
About?
I saw big materialized views, and even if, like, again, the idea of big result, big materialized view comes from my idea. Let's not create a materialized view for each query. Let's create it for to avoid joins, for example.
Yeah.
Right, and then run a lot of various queries on top of it. Quite good idea. It's like denormalization, automated denormalization, basically. But even if people just use it for a final query, just cache the result of query, I still saw huge materialized use. Huge.
Interesting.
It happens.
Oh, great. Sounds good.
And if it have it huge, it should be partitioned to benefit from it. But the main key, I would highlight the key point here. Postgres unfortunately doesn't have this, what Oracle has, pragma autonomous, the ability to initiate transaction which will be detached from a trigger, for example. So I want to have insert, but a database will guarantee it will be finished, but it's not my problem already. I finish my transaction and another transaction is happening in different backend, for example. You can do it with DB link or something, emulated it, but it's like it looks not clean solution. Currently I see ideal system, what I would build. I would use tables. I would store definition, maybe not in Postgres, maybe inside. I would maybe partition result, but first thing I would solve, of course, I would propagate changes incremental fashion, not refreshing whole view. And by the way, there are articles explaining how to do it. And there are also tools for various languages which help you to do it. But first thing I would do, I would propagate changes asynchronously through probably something like Kafka, I don't know. I can implement it in Postgres, but it requires additional knowledge. You need to know how to deal with bloat. It's kind of queue inside Postgres. Maybe we should cover this topic separately. It's possible, but if it's in Kafka, it's also good, or some other system which doesn't lose data, allows me to control the lag, and it just delivers this signal of change separately, so I can update my target. And the project, I sent you the link, this Materialized, company called Materialized. Yeah. They solve it as a commercial solution. And as I understand, they use Kafka and Debezium. Everyone can do it, but maintaining Kafka, it requires additional efforts. So that's why maybe I would do it in Postgres itself. It depends on the system. If you have many databases, having Kafka as something like additional to Postgres, it would be justified, right? But in this case, imagine it's ideal world. The target is good. I mean, it doesn't suffer from having huge tables and very long vacuuming. Indexes are usually smaller because it's partitioned. Index maintenance there can be applied in regular fashion. And changes are propagated atomically, like every small change is propagated, guaranteed with small delay. And for example, if we have a lot of posts, comments like social media, or for example, Twitter, there's Mastodon thing, this like people migrated, it's running on Postgres as well, right?
It is, yeah.
We have tweets, for example, answers, replies, likes, everything. And we can have counters very, very, very good here, like using this approach. Like, so I wonder why development goes this direction, which will not work well for very large volumes of data. Well, I see the use cases where it will be useful, this incremental view maintenance. But why these two big problems ignored? And first of all, this ability to propagate changes asynchronously. It's so, like, I think this problem should be solved first. To allow people to define triggers which will be asynchronous, for example, or something. Yeah. Or maybe it should be done outside of database. It's not closed topic for me. I don't know the ideal answer here. Maybe Kafka should be here. Or maybe it should be done in Postgres. I don't know.
Well, if anybody out there has done a lot of thinking and reading about this, let us know how you would, what your thoughts are. Also, I'm really grateful to the people that are working on this, on the pgIVM thing, because they are looking to contribute this to Postgres. They are looking to get it committed upstream. And I think that's a really nice use of the extension model, where you write an extension as a proof of concept. Well, what do you think?
Yeah, I agree. I don't want to discourage and just to criticize. I just see that problems that should be solved also. I solved it a couple of times in different cases. Not as open source, just solved it, and it was good. But maybe. I remember also discussions implementing this Pragma autonomous in Postgres. Unfortunately, also didn't finish. So the need of it is there. Incremental view maintenance probably will be good for mid-sized projects, but for larger scale, like dozens of terabytes and hundreds of thousands of transactions per second, multiple standby nodes and so on, we do need additional thing to be solved as well. I feel it. And currently solvable with Kafka or something. Maybe it should be. Maybe these things, like regular discussion, should it be inside the engine or should be outside? I don't have exact answer for this. But it's super interesting topic. I think in general, development of materialized use can be helpful for many, because data volumes are growing and people want aggregates run faster and so on and so on.
Yeah, exactly. More and more products need to have a dashboard, have some, a lot of even transactional products are expected to do a little bit of analytics now as well, aren't they? So it makes a lot of sense.
Yeah. Well, actually, maybe it's not that bad. If you like, I would right now consider pgIVM for a particular project. I would just measure, benchmark how my writes will slow down because of this synchronous propagation approach. Also, it requires an index, right? So additional index, which also will slightly slow down our writes. But and if it's acceptable, and if it will remain acceptable in few years when my data volumes will grow, then I would just use it. Why not? And it solves the problem of this very rough approach, like let's update as a whole. It updates only part of it. It's good.
Yeah, right. Keeps everything in Postgres at the start too. Well, good luck to them, and thank you. Everything. Did we cover everything you wanted to here?
Yeah. Maybe some bottom line, check, benchmark, and consider it building your own solution based on just create table select, some triggers, maybe Kafka, or some asynchronous queue mechanism you have already, if it's reliable, of course, and you can propagate and support your own data structures and queries, maybe, right? While, like, I mean, if existing solutions are not don't suit well for your needs, maybe you just need to write your own thing. It's not that difficult actually, right? You have rules, you have triggers, so just do it.
Triggers, yeah, for sure.
Triggers here, yeah. I think about triggers, but synchronous nature would be good to have here. Yep, that's it. I would just to warn, like, refresh Materialized view is good as like quick and dirty solution. It will be dirty because it will hurt when data grows and everything grows, and like it will be problematic for large volumes of data, even concurrently.
But it can get people a long way, right? At the beginning.
Yeah.
And yeah,
well,
I think
I'm talking about dozens of terabytes and dozens or even hundreds of thousands of transactions per second. It's like really big systems. And also Materialized companies, they do interesting things. It's commercial but interesting. And there is a talk. There are a couple of talks from them. I've checked them. Quite interesting. Very interesting. Just to understand how it's implemented, how the vision and so on. Let's also link their materials.
We'll do.
Materialized materials.
Yeah. Well, yeah, I hope a few people got some ideas of things they can use these for as well, even in the current state. And yeah, look forward to speaking with you next week.
Good. See you later. Bye.
Bye.